Hello everyone, this is video 12.6. We're going to be looking at the area and circumference of circles and introducing the number pi. Uh, I'm going to assume to some extent that you're familiar with some of these ideas, so this is going to go relatively quickly, but I'm still going to go through and explain some of these ideas, and then at the end, uh, there's kind of a little bit of a surprise as far as how we're going to be thinking about some of these topics. That's going to be a little bit different than what we've done in the past. So uh, stay tuned for that at the end. So let's get started. So we've got some definitions we got to get through. The circumference. The circumference is the distance around a circle. Now we have to be kind of careful because we might think of this like perimeter, but we shouldn't really call it the perimeter when it comes to a circle. And that's because a perimeter implies that there are sides. So if you find the perimeter of a square, you add up those four sides. If you wanted to find the perimeter of a triangle, you would add up the lengths of the three sides. But in the case of a circle, there's not really what we would call sides. There's not any straight objects that form sides. So the way in which we find that circumference is very different from how we find the perimeter of a quadrilateral or any of the sort of polygon. So there is a distinction between the two. And so, I hear teachers sometimes say that circumference and perimeter are the same thing. They're the same idea because we're still talking about distance around an object, but they're not exactly the same thing. And there's a really important distinction between the two. Radius and diameter, we've talked about before. We know radius is the distance from the center of the circle to any point that's on the circle. So from the center out to any of those points, and we know that the radius is a constant length. So whichever point I pick on the circle, that distance from that point to the center is the same as the distance from any other point to the center. All those radii, the plural there, radii, are of constant length. The diameter we can think of as twice the radius, but really we want to think about that as the distance from a point on the circle through the center to the point on the other side. And the reason why I'm being kind of picky about this now is because if we draw a circle and we take a center point and we take this radius and this radius, well, these two lengths together are twice the radius, but it's clearly not a diameter. So these two segments together form 2 times the radius, but they're not a diameter. So I want you to think about the diameter in terms of how it's constructed. I would pick some point on the circle. I would take this segment from the point to the center. That's a little wavy there. Let's fix that. So I'm going from here to here, and then carrying through that center point to this point on the other side. So there's a line going through this starting point and then the center, and it's going to hit a distinct point over here, a unique point. And so this length here is my diameter. And now it also clearly has a length of twice the radius, of double the radius. So each of these would be radii. So this whole thing is the distance. This would be a radius. This would be a radius. But we want to be a little bit more specific, so we rule out cases like this. Pi. Pi is our constant of proportionality of a circle's circumference to its diameter. In other words, if I take any circle and I take its circumference and I divide it by its diameter, I should get this value here of pi. Now, we're going to just use as our approximation 3.14. Some of you may already know that this pi is an irrational number, which means that it can't be written exactly as a fraction. And so this 3.14 is an approximation for something that keeps going. It's a decimal that doesn't stop and doesn't have a pattern. We're not going to get into a ton of that. Irrational numbers are mentioned a little bit in 137, and so we're going to mention it a little bit here. But if you happen to know a lot more about these sort of interesting characteristics of pi, that's fantastic, but we're not going to get into a whole lot of detail with that in this class. So I found this picture online when I was looking for the relationship between the circumference and the diameter. And there's a picture similar to this in the book, and I wanted to go through and explain it. So when you see it in the book, it makes it makes a little bit more sense. And this is also an activity that you could do with your students, so they get an idea of about how far pi is. And so what's happening here is we have this point here fixed on the circle, and then we're going to roll this circle out. So it's being rolled out until this point right here hits again here. And so as it is rolled, this point, this point, this point, so all these points are going to sort of, as the circle rolls along this segment. So what we've done is we've taken this circumference and we've laid it out as a straight line rather than as a circle. So the idea is that this distance here, this is my circumference as a linear distance. And so by rolling this circle, and we can do this with a can or a paper towel roll or any kind of circular thing. We just got to make sure that we mark where the starting point is and then roll it from here. Now we can measure this diameter, and then once we've measured this off, we can start to mark it off on this length, and we should find that it marks off 1, 2, 3, and then this little bit here. And so this would be my about 1400ths. It should be about my 0.14 is what I was trying to say, but it came out as 1/4. So this should be my 0.14 here approximately. It's a good activity, so that way students kind of get some experience with thinking about how to find this circumference and roll it out into a linear distance. And hopefully at the end of this, if students just know that pi is 3 and a little bit more, I think this activity's done its job. This 0.14 is going to be really hard to get at. It's going to be really hard to do. Now, if we can measure out what this diameter is, and let's say that it's like 4 inches, then we start to measure off, okay, this is 4 inches, this is 4 inches, this is 4 inches, and then we measure out what this is and then divide it by 4, and we should get something in this ballpark. But because of error in measuring, error in rolling out this circle, any number of things that could introduce like just a small little bit of error, we might be off of this 0.14 by a fairly significant amount. So we're not doing this activity for precision. We're doing this activity to sort of introduce the idea about pi and see this relationship between circumference and diameter, but also so students get a sense of this relationship and an approximation for this measure. So we're really not worried about precision. Like I said, we just want students to have an idea that it's a little bit more than 3. So we've already seen on the previous slide that C over D, this fraction here, the circumference over the diameter, gets us this pi. Now, if we multiply both sides by D, we get this form. And so this would be the circumference equals the diameter times pi. And then since we know that the diameter is 2 times r, I can replace this d with this 2 and this r, and so I get circumference is 2 times pi times the radius. So you'll see these two forms, and probably this CD pi, or C equals circumference equals diameter times pi. This is the one that you'll see probably the most often, but you'll also see it like this sometimes. And then to reinforce pi as this ratio, you'll see it this first way as well. So be prepared to see this formula and all 3 of these equivalent forms at some point during the time when you're teaching this topic. So the last thing to cover is the area formula for a circle. And the area formula is the area is pi times the radius squared. So if I have a circle, let's say that my radius here is 5 inches, then my area is going to be pi times 5 squared inches squared, which is 25 pi inches squared. Now, if I want, I can grab a calculator and approximate this out. So now this is going to be approximately 25 times 3.14 inches squared, which comes out to 78.5 inches squared. So if we want, we can use this to approximate it. Leaving it in pi, in terms of pi like this, is going to be an exact amount, so I can use an equal sign. If I substitute this 3.14, then I got an approximation, and I need to use this approximation symbol, the equal with the tilde on top of it. So this is the part that I mentioned earlier is a little bit different than what we've done so far in this class. The reality of it is this formula and exactly where this formula comes from and how to like prove or derive this formula is well beyond this class and well beyond what you're really going to be expected to teach in a class. We'll look at an activity that allows us to sort of roughly approximate this formula, and we'll get an idea, we'll get a rough sense of how this proof and derivation comes about. But the reality of it is, this is going to be one of the very rare times where I say this. It's going to be okay to just give the formula and have students work through the formula. There's a concrete representation that, like I said, that we can look at and that we'll see. There's the abstraction, which is the formula. But the steps from that concrete representation to that formula are a lot more complicated than anything else we've really seen in this class so far. So this is going to be one of the rare times where you're pretty much just going to have to tell students, you'll see it later. You'll do it later. You'll understand it a little bit more later. It's still worth going through that rough approximation concrete model and showing that we'll see in class. But it's going to be almost impossible to really fully explain where this formula comes from. I hate saying that. I hate being in a position to where we have to tell students, just trust me. Just do it because I'm telling you to do it, and just trust me that it works. But this is one of the rare instances where you really don't have much of a choice. The difficulty is just a little bit too high for this idea. So for your checkpoint, I want you to find the area and circumference of a circle with radius 3 and another circle, so 2 circles here, with a radius of 9. And now what do you notice about the relationship between the radii of the 2 circles, the circumferences of the 2 circles, and the areas of those circles? We've looked at this idea before, just not with circles. So hopefully you can make the connection between this question and some stuff that we've seen not that long ago. So if you have any questions about this problem, anything else, or how this problem connects to other problems that we've seen, as always, bring those questions to class and we'll get them answered. All right, thanks.